I was at MathsConf just on this Saturday, yesterday, and explaining the formula that you can work out the number of factors that a number has based on its prime factors. So I thought I'd just go through try and explain that more clearly because I didn't have time in the presentation to do that. So I used 18 as the example. So 18, if written as a product of its prime factors, is 2 times squared. Okay, and then I can see it's got base number 2, which has which is raised to the power of 1, and then 3, which is raised to the power of 2. So let's deal with that. And first of all, let's get rid of everything that's bigger than 18. We definitely won't need that. And we can get rid of anything that is not contained within 18 in terms of the prime colors. One way, so there we go. 6 is good. We can put 6. We can keep 6. We can keep, no, 4's got 2 reds and there's only 1 red in 18. So that's kind of the idea that we have. So we can now get rid of everything and we should end up with the factors of 18. So let's put 18 in and then we can arrange them. We can see there are 6. And the formula states that we should have, if we imagine the powers, so, there's 3 to the power of 2, we take that index 2, and we're going to add 1, and that will give us 3. And then we get the other base number, which is 2, and that's raised to the power of 1, so we're going to have 1. We're just going to add 1 to that, make 2. And 3 times 2 is the number of factors. You can see, hopefully know that 18 has 6 factors. So it would be worth looking at perhaps how that can be seen or experienced, I suppose, using prime colors. So let's see, we've got these 6 factors, and just to go over it, it's like we've got 2 raised to the power of 1. We're going to add 1 to that, that's 2, and then 3 raised to the power of 2, that's where we got the 3. Let's see how that actually works. Because I've set it out as a grid here, 2 times 3 grid. So let's see if we can use our grid to show this idea. So I'm going to rearrange these a little bit, and I've rearranged them to this because so now they're organized in terms of their prime factors. Let's see how they are organized. So I have got my 2 by 3 table, and then I've got the 2 rows, and I've got the 3 columns. And hopefully you can see that I've got in the bottom row I've got no reds, and in the top row I've got 1 red. And in terms of reds, that's the only possible combination. I've either got 1 or none. So that makes 2 rows, and that gives us the 1 plus 1. And then in the columns I've got either no green, 1 green, or 2 greens. And that's the only possible combination of greens, and that's why I've got 3. And that's kind of it. That's the idea. So if you've got, now this is especially visible in where we've got just two base numbers or colors, but that it will hold with, it holds with however many colors you have in your number. So we can see then why, let's say if I take 20 has the same setup, if you like, in terms of there's one blue and 2 reds. So I can just change this. So I'm going to change this to well, let's change that one to blue and these ones to red, and then I should have the same number of factors. Let's have a look. See the same, either 0 reds, 1 red, or 2 reds, and then either no blues or 1 blue, and this should be all the factors. And you can see there's 1 and 5, that's 2, and that's 4 There you go. So that's the idea. Now, it might be worth then trying the same thing for 72. So given that these are the prime colors for 72, how could you work out the number of factors? Now, you might want to pause the video for a while and see if you can work it out, and then we'll go through the explanation. So you can hopefully see that there are 3 reds. So we're going to need 4 columns for the reds, and there are 2 greens. We're going to need 3 rows for the greens. Do it the other way around, of course, it doesn't matter which way we do it. And then let's see if we can put those out. So we've got the 4 columns, 3 rows, and for the reds, we've got either no reds, 2 reds, or no reds, 1 or 2 or 3 reds. So 4 possible combinations. And then for the greens, we've got either 0, 1, or 2 greens. And then we can make the combinations we want. You can see the power of a grid. Of course, that was the other kind of main model that I promoted in my talk. And there we can see all of the factors. And another useful thing I suppose we can always do is actually link up the factors. So I'm linking up there 1 and 72 as a pair of factors that make 72. And then I could link up those ones 4 and 18 as another pair of factors that make 72, and so on. And of course you could do this, you'll find pairs of factors for all of them, except for certain numbers, of course, but we won't go into that. And that's, I think really helpful in getting a deep understanding of the ideas of factors. So yeah, there you go. Hopefully, whether or not you were at my presentation, this is useful for you. And to the person who asked, sorry I didn't get back up with you, but yeah, hopefully that explanation works.